Okay, welcome to Systems of Linear Equation, Part 1, Identifying Solutions to a System. Before we get started, since this is a brand new objective for us, let's go ahead and look at what we are required to do. The objective is to identify solutions of systems of linear equations in two variables. And what we mean by two variables, we're talking about x and y, or a and b. We want to solve solutions of linear equation in two variable by graphing. This is what we're going to do first, but before we have to make sure that we get a basic understanding on how we determine what will be solutions. So let's take a look at some vocabulary first. We say that a system of linear equation is a set of two or more linear equations containing two or more variables. And a solution of a system of linear equation is an ordered pair. So we mentioned graphing, so that means we're talking about the x and y on the coordinate plane. So we say that an ordered pair that satisfies each equation is in the system would be a solution to that system. So if an ordered pair is a solution, it will make both of the equations or three of the equations, it all depends, because we're talking about two or more. So right now we're going to just deal with two, so both equations will be true. So let's take a look at an example. We want to just tell whether the ordered pair is a solution of the given system. So they're giving us a solution of 4, 1. Now again, this is x and y. Take care of this line. So we're talking about x and y. Okay? So when we look at this equation and determine if it is indeed a solution, or actually if the ordered pair is a solution, we first must solve each equation at a time. We have 2, x plus 2y is equal to 6, and x minus y is equal to 3. So if we look at the textbook, it gives us a t-chart. Let's see, we can draw this particular t-chart. We'll make it a little bit conducive to understanding. So let's go to create a different line. Okay, and yeah, that's better. Okay, so let's just start off by putting our actual equation on the top here of our t-chart, and that will be x plus 2y is equal to 6. Okay, so we good and started. So the only thing we have to do is simply substitute 4 for x and 1 for y and solve. So let's just go ahead and do that here. So that's giving us actually we have an equation here, so let's go and make that 4 plus 2 times 1. That's our y value, and it's supposed to equal to, and that's what this line means. This line right here means equal, so we'll say 6. So let's continue solving on the left. That's 4 plus 2 is equal to 6. And then of course 6 is equal to 6. So that's telling me that this is a solution to this particular equation. Okay, so let's take a look at the second part and see if it works for part 2. Again, we're going to look at x plus y, so I'll go ahead and change my color back. my standard blue. Go ahead and make my T-chart for the second one. Now, so now we're looking at our equation of x minus y. X minus y is equal to 3. Okay, so again we know that x is 4 minus y is 1, and that should equal to 3. So we do our math here. 4 plus a negative 1 is the same thing as 1 take away from 4, or 4 minus 1. That's going to give us 3 is equal to 3. Okay, great. So as we can see, that it's also true for that particular equation. So that tells us that 4 comma 1 is a solution to the system x plus 2y is equal to 6 and x minus y is equal to 3. So let's take a look at another one and make sure that we're on, if this one match up or not. Okay, this is not in the textbook, but you'll be able to follow along, because by now you see it's quite simple. Okay, so again I want to construct my T-chart right there. Let's just a little too big. Start here, and that's probably good enough. Okay. So let's go back to the pen, and we'll do this one in red. Okay, so we're talking about x minus 2y is equal to 4, and 3x plus y is equal to 6 is our system, and we're asked to find out if the ordered pair 2, negative 1 will be a solution to the system. So let's go ahead and begin with x minus 2y is equal to 4. Okay, so it gives us x is 2, so we just substitute. Now let's be careful here. This is minus 2 times a negative 1, and that again should equal to 4 is what they're telling us. So let's do the work. So we have 2 and distribute a now let's go ahead and make this plain, because I know how we have our problems with integers. So let's just change this to plus, again same opposite, a negative 2 times a negative 1. Okay, you see it there? And that's going to equal 4. So now we're looking at actually so let's go ahead and 2 plus a negative 2 times a negative 1, or let's just do it. 2 times 1 is 2, but a negative times a negative gives us a positive, so this will be 2, and we're looking at our answer should be 4, and then of course 2 plus 2 is 4, and that's 4, and it checks. Okay, so this is telling me, go ahead and extend my little line, and we just try to stay in format. Yeah, that's fine. So this is telling me that the ordered pair 2, negative 1 so far satisfy the first of our system, x minus 2y is equal to 4. So now what we need to do is determine if it will satisfy the second. Okay, so let's just go ahead and bring it over a little. We're running out of room here, but what I'll do is I'll just go ahead and put it in the middle over here. I don't think that's going to hurt us too bad. And we can still see exactly where we are. We'll just bring it down here. Okay. So now we're looking at the equation 3x plus y is equal to 6. And again, we're using 2, -1. So now we're looking at, let's see, this will be 3 times 2. Now look at here. Plus a -1 is equal to 6. Don't forget that -1 and what it represents here. So now we're looking at 3 times 2, which is 6, plus a -1 is equal to 6. Okay, so let's take a look at when we are adding integers with different signs. We see that we take the absolute value of the smaller. Here's a -1 and subtract the absolute value of 6, and we will see that 1 from 6 actually is going to give us 5, and 5 is not equal to 6. So as we can see, this is not the ordered pair 2, -1 is not a solution to this system of equations. Okay, and we found out on the first one. Now remember what let me say, I don't think we really delve into this, but if you are solving this system and the first is true, in this case we're looking at 2 plus 2 actually is equal to 4, and of course 4 is equal to 4. Now we look at the second one and we have 6 plus a -1 is equal to 6, and 5 does not equal to 6. So what we're saying, what I want you to understand, that if you're solving a system and it's true for one equation and false for the second equation, then the ordered pair is not a solution to the system. If you were doing this equation, if we were doing this equation and we worked the first equation and we came up with a false for 5 is not equal to 6, that particular contradiction, then we would need not to work the second, because automatically we would know that this ordered pair would not be a solution. Okay, so that do it for identifying. That will take that identifying this solution, this solution to system. So hopefully you guys can take a look at some of the problems in the textbook and easily work this. If not, then just come on back to the DVD and I'm sorry, to the video and take a look until you pretty much get it. But again, keep in mind that both equations have to be satisfied by the ordered pair. And then the first one that happens, which is good, then we take a look at the second one. We can see that 2, -1 does satisfy the first equation. It does satisfy the first equation. But when we look at this second equation, and we can automatically see that it does not, even if that would have been a positive, it would not have satisfied this second equation. So of course this is not, so this ordered pair is not a solution. Okay, all right, that does it. See you next time.